Sauropod dinosaurs are instantly recognizable. These magnificent creatures roamed the Earth millions of years ago, leaving an indelible mark on the history of life. They are famed for being the largest land animals to ever walk the Earth. Their sheer size and presence have fascinated scientists and enthusiasts alike. These incredible creatures possessed colossal bodies, long tails, and most notably, extraordinarily long necks. Their necks were not just for show, they played a crucial role in their survival. Their necks are a marvel of evolution, showcasing an unparalleled adaptation that allowed them to thrive for millions of years. By reaching high into the trees, they could access food sources unavailable to other herbivores. In this exploration, we delve into the fascinating world of sauropods to understand how these gentle giants evolved such impressive necks. Their evolutionary journey is a testament to the power of natural selection. These iconic necks were not merely a product of chance. They were a sophisticated adaptation that provided numerous advantages in their environment. They were the result of millions of years of natural selection. Over time, sauropods with longer necks had better access to food and could outcompete others, leading to the gradual elongation of their necks. This process favored individuals with traits that gave them an edge in survival and reproduction. The longer the neck, the more leaves they could reach, and the more likely they were to thrive and reproduce. Over countless generations, sauropods evolved longer and more efficient necks, pushing the boundaries of what was possible for a terrestrial vertebrate. Their story is a remarkable example of evolutionary innovation and adaptation. The story of sauropod neck elongation begins with their ancestors, the Sauropodomorphs. These early dinosaurs, while not as large as their later relatives, already possessed relatively long necks compared to other herbivores of their time. These necks, though modest in comparison to later sauropods, provided a crucial advantage in reaching higher foliage. This ability to access food sources unavailable to other herbivores provided an evolutionary edge, setting the stage for the remarkable neck elongation seen in their sauropod descendants. These early adaptations highlight the power of natural selection in favoring even subtle advantages, ultimately shaping the trajectory of an entire lineage. The evolution of long necks in sauropods was primarily driven by the availability of food. As these dinosaurs grew larger, they needed to consume vast quantities of vegetation to sustain their massive bodies. A longer neck provided a distinct advantage in reaching a wider range of food sources. With their elongated necks, sauropods could access foliage high in the trees, out of reach of other herbivores. This allowed them to exploit an abundant and relatively untapped food source, giving them a competitive edge in their environment. This constant pressure for efficient foraging played a pivotal role in shaping the sauropods' iconic long necks. The incredible length of sauropod necks was made possible by a suite of remarkable adaptations in their vertebrae, the bones that make up the spinal column. These adaptations were not just minor tweaks, but significant evolutionary changes that allowed these magnificent creatures to thrive in their environments. One key adaptation was an increase in the number of cervical vertebrae. This increase was not uniform across all sauropods. Different species evolved varying numbers of neck vertebrae, which contributed to the diversity in neck lengths observed among these dinosaurs. While most mammals, including humans, have only 7 neck vertebrae, sauropods evolved to have as many as 15 or even more. This dramatic increase in vertebrae count was a crucial factor in their ability to develop such long necks, which were essential for their feeding strategies. In addition to having more vertebrae, each individual vertebra was also significantly elongated in sauropods. This elongation meant that each vertebra contributed more to the overall length of the neck, allowing these dinosaurs to reach higher vegetation and cover more ground without moving their massive bodies. This elongation, coupled with the increased number of vertebrae, contributed significantly to the impressive length of their necks. The combination of these two factors allowed sauropods to become some of the largest and most efficient herbivores of their time. Furthermore, sauropod vertebrae were filled with air sacs, a process known as pneumatization. This adaptation was crucial in reducing the overall weight of their necks, making it easier for these giants to support and maneuver their long necks. These air sacs connected to the respiratory system made the bones lighter without compromising strength, allowing for the evolution of such long yet lightweight necks. This unique combination of adaptations showcases the incredible evolutionary ingenuity that allowed sauropods to dominate their ecosystems for millions of years. Section 5. Mighty muscles and tendons. Supporting the giants, having a long neck is one thing, but supporting and controlling its movement requires an equally impressive muscular and tendinous system. Sauropods evolved powerful neck muscles and strong, flexible tendons that anchored the neck to the body and allowed for a surprising range of motion. These muscles and tendons acted as a sophisticated system of cables and pulleys, enabling the sauropod to lift and lower its head with control and precision. This muscular system, along with a unique arrangement of ligaments and cartilage, provided the necessary support and flexibility to maneuver their massive necks efficiently. Section 6. High browsers, the advantages of a long neck. The long necks of sauropods are considered a classic example of an evolutionary adaptation driven by feeding ecology. Their extended reach allowed them to access a greater diversity of plant life compared to their shorter-necked counterparts. They could graze on low-lying vegetation, reach up into the canopy, and even extend their necks horizontally to sweep across vast areas. This ability to exploit a wider range of food sources offered a significant advantage in environments where resources might have been scarce or seasonally limited. The long necks of sauropods were not merely a case of bigger being better, but a finely tuned adaptation that maximized their foraging efficiency. Section 7. Small head, big advantages. Interestingly, the evolution of long necks in sauropods was accompanied by the development of relatively small heads. While this might seem counterintuitive, it was actually a crucial adaptation for maintaining balance and minimizing the energetic costs of supporting such long necks. A large, heavy head at the end of a long neck would have required significantly more energy to lift and control. The small head of sauropods helped to offset the weight of their necks, allowing for more efficient movement and reducing the overall energy expenditure associated with their massive size. Section 8. Debates and discoveries, unraveling the mysteries. Despite decades of research, many aspects of sauropod neck function and behavior are still debated among paleontologists. One ongoing debate centers around the flexibility of their necks. Some researchers believe that sauropods had relatively inflexible necks, primarily used for vertical browsing, while others argue for greater flexibility, allowing for a wider range of motion. Another area of debate concerns the social implications of long necks. Some scientists speculate that long necks may have played a role in sexual selection, with males potentially using their necks for display or even combat. These ongoing debates highlight the dynamic nature of paleontological research and the exciting discoveries that continue to reshape our understanding of these ancient giants. Section 9. A marvel of evolution, the sauropod neck. The evolution of long necks in sauropod dinosaurs stands as a testament to the power of natural selection. These gentle giants roamed the Earth millions of years ago, and their unique adaptations allowed them to thrive in various environments. Their necks, which could reach incredible lengths, were not just for show, but served a critical purpose in their survival. Driven by the need for efficient foraging, these remarkable creatures developed a suite of adaptations that allowed them to achieve unparalleled neck elongation. Their long necks enabled them to access food sources that were out of reach for other herbivores, giving them a significant advantage in their ecosystems. From the increased number and length of their vertebrae to the intricate system of muscles and tendons, every aspect of their anatomy was optimized for supporting and controlling their massive necks. The vertebrae were hollowed out to reduce weight without sacrificing strength, and the muscles and tendons were arranged in a way that maximized efficiency and flexibility. The long necks of sauropods not only shaped their feeding ecology, but also influenced their overall body plan and likely played a role in their social interactions. These necks may have been used in displays to attract mates or to establish dominance within their groups, adding another layer of complexity to their behavior. These magnificent creatures continue to captivate our imaginations, reminding us of the incredible diversity and grandeur of life that once roamed our planet. Their long necks are a symbol of evolutionary ingenuity, showcasing how life can adapt in extraordinary ways to meet the challenges of survival. As we study these ancient giants, we gain a deeper appreciation for the wonders of natural history and the intricate web of life that has shaped our world.